Hello everyone, myself Professor Tushar Gujarati from S.N.D College of Engineering and Research Center Yeola. Today we'll study the experiment number 5 of the subject mechatronics, and the experiment is digital to analog converter. So many times we require the digital form or digital signal we have to convert into analog form. So for this purpose we require digital to analog converter. Okay, so let's study this. So what is objective of the experiment? Objective is to study the 8-bit digital to analog converter. Now today we are going to study 8-bit digital to analog converter. So as you know that digital signal consists of bits, that is binary numbers. Okay, so the digital signal may be of 8-bit, it may be of 16-bit, or it may be of 4-bit also. Okay, so in this case, in this experiment we are going to study only 8-bit digital input signal, and we should get analog output signal for the same. Okay, so what is outcome of experiment? So the student must be able to explain conversion process of digital to analog converter. So you should be able to explain the conversion process. Okay, so this is outcome of experiment. So what is DAC? DAC, the full form is digital to analog converter. So this digital to analog converter converts digital signal into analog signal. So digital signal is in the form of 0 and 1. So that is called as binary number. So in this case you can see this is the digital number 100111010. This is the binary number or digital signal. This digital signal is given as an input to this digital to analog converter, and this converter converts the digital signal into analog signal. So analog signal may be in the form of voltages like plus 5 voltage, plus 5 volt, or 7 volt, 8 volt. So like this binary number, 8-bit number, is converted into analog signals. Okay, so this is the digital to analog converter. So what is procedure of this experiment? We'll read this one by one. So what is first point? Connect mains cord to 230 volt 50 hertz AC supply. So what is input here? 230 volt 50 hertz AC supply. Now switch on the trainer and see that supply indicator glows on. So when you switch on the trainer, the light will glow. Okay. Now second point, select V reference 1 by patch cord. Now here we have to select V reference 1, reference input voltage we have to select. Okay, and select 11110000 input. So we are going to select 8-bit binary word, okay, as an input, and measure the output voltage by digital multimeter, and then we can measure digital output voltage by digital multimeter. Okay, then next point, also measure V reference 1 voltage by digital multimeter. So we have to also measure V reference 1 voltage by digital multimeter. And next, select different input digital words and measure output analog voltage. So we have to give different input digital words, combination of 0 and 1. We have to give different digital input words, and we have to measure output analog voltage for the same, and record your readings in observation table. So this is the procedure. So now this is the digital to analog converter setup. So in this case you can see that this is the digital to analog converter. Okay, so to this digital to analog converter, the input is given from this point. So this is input supply. So here it is written V reference 1 and here it is V reference 2. So both the voltages are different. So V reference 1 is plus 5 volt, okay, and V reference 2 is 2.5 volts. Okay, so like this they have given us two combinations, plus 5 volt and 2.5 volt. So we can select any one out of them. So suppose we want to use V reference 1, then we will connect this with the above wire. Okay, then we will get V reference 1 as an input. Okay, so this is the input signal to the converter. And now where is the output? So here this is the output terminal, and you can measure output to this terminal and between this ground. Okay, here you can measure the output. You will get output voltage over here. Okay, so output to voltmeter is written over here, so you can measure output to this side. Okay, now the input. Okay, so input is 8-bit binary word. Okay, that's why you can see here there are 8 numbers are written like this: d0, d1, d2, d3, d4, d5, d6, d7. So these are all 8 inputs are shown here. So here we are going to give different binary inputs or different digital inputs like in the form of 1 and zeros. Okay, so now you will there is one question that how you can give 1 and 0 to this circuit. Okay, so here the logic 1 is given here. Logic 1, you read the statement logic 1. So all these inputs are logic 1. Red colored part is logic 1, and here you read logic 0. Okay, all black colored parts are logic 0. So when you connect particular wire in the logic 1 and in the logic 0, so that will be input to that digital analog converter. Okay, so like this is the construction of our setup. Now next, now you check here the setup. So what we have done here, you check, we have selected a V reference 1 as an input supply. Wire is connected here, V reference 1 is input supply. Okay, and now logic 1 and logic 0 are selected. So when wires are connected in this form logic 1, okay, and when they are connected in logic 0, okay, so this is called as logic 1 and logic 0 lines. So like this, here we get input as 1 1 1 1, and here we'll get 0 0 0 0. This is the input right now, and we have to measure the output over here voltage with the help of digital multimeter. So right now you see that these 4 0 are connected over here, and once whatever 1 are there, the 1 should be connected here actually. Okay, the mistake is done here, something mistake is done. So so rather than connecting these ones, this whatever terminals are there, this should be connected over here. Okay, something mistake is done here, so you should understand this. As we have connected 0 to this terminal, so 1 should be also connected like this over here. 4 wires should be connected in these 4 blocks. Okay, so something mistake is done here while connecting the diagram. So next, what is observation table? See, in the observation table you see we have to give different digital input data in the form of 1 and zeros. Then we have to calculate output voltage. There is one formula is available. With the help of formula we have to calculate output voltage, and we can measure output voltage through multimeter also. Okay, so this is with the help of formula, and this is from experiment. Okay, so both should come, actually both the readings should be close to each other. Okay, so this is the formula and experimental readings. So like this we have to note down for all the combination of 0 and 1 what is the calculated output voltage and what is measured output voltage. Okay, this you can measure. Now this is the formula for calculating analog output voltage. So what is formula? V0 is equal to D7 divided by 2 plus D6 divided by 4, D5 by 8, D4 by 16, D3 by 32, D2 by 64, D1 by 128, and D0 by 256, and multiplied by V reference. Okay, so now in this formula what is D0 and D7? So these are all data inputs, 0 and 1. Okay, so we have to put here values of 0 and 1 in the place of D7, D6. Suppose our number is 1 1 1 1 and 0 0 0 0. Okay, so here these are numbers. So this is D7, D6, D5, D4, D3, D2, D1, 0. So your value of D7 is 1, D6 is 1, D5 is 1, D4 is 1. So we have to substitute these values in this formula. Here 1 1 1 1. Okay, and D3 is 0, this is 0, this is 0, this is 0. So like this we can calculate. And what is V reference? I already told you we have selected V reference as 5 volt for the circuit. So V reference is 5 volt, and like this you can calculate output analog voltage. We can calculate V0 as an output analog voltage, and this calculated we have to write down in this second column, calculated output voltage. Okay, and what is measured output voltage? Measured output voltage we'll get from this terminal. Okay, with the help of multimeter. So here you can plot graph between digital data input on x-axis versus analog output voltage in y-axis. Okay, So you can give here some digital input data. Okay, you can write digital input data and you will get some output voltages over here. So you should get something increasing or increasing graph. Okay, so like this you will get graph. And what is conclusion after studying this? So from observation table and graph it is found that the digital input is converted into analog output voltage. Okay, so digital input is converted into analog output voltage. And second point, the measured output voltage and calculated output voltage are nearly same. So there is little bit difference between measured and calculated output voltage because of fluctuation in voltage while taking experiments. Okay, so there is little bit difference. Okay, so like this we studied digital to analog converter in this video. So thank you so much all of you for watching this video. Thank you so much.